I hope you all can hear me and see my screen. If not, just please put it on the chat. Is David, my co-host, here? Great, thank you, Dan. Well, everybody, welcome. We'll wait for people to trickle in, but I was curious, in the meanwhile, I would love to know where everybody is from and if they're teachers, what the demographic of the students are like. Are they high school teachers? Are they teaching in colleges? Are they teaching online? I would just be curious to just learn more about that. LA Middle School Science, great. That's Jason. Okay. Wow. Okay, so a lot of middle school, high school teachers, beginners, advanced seniors. All right, all right. So I'm just gonna give it a minute or two more. David, I hope everything's in order on your end in terms of moderation, co-hosting, and so on. High school intro Python, APCS, great. Nice. Is anybody from Canada? I'm actually presenting from Toronto, Canada. So shout out to whoever's in Canada. Coder Dojo, adult AI ML workshops. Wow. Hey, Elliot, sorry, you want to say something? Okay, David, I'll let you handle moderation. Okay. All right, I think I'm gonna just get started and I think people will come in. So thank you everybody for joining. This is a little last minute for me, but I'm super, super excited to tell you all about Replit's AI features, especially with a lens for education. I'm Madhav. I work on the data AI team. I joined about 3 months back, and it's my team which builds a lot of these AI features, conceptualizes, builds, and lays out the infrastructure to build all these features. So yeah, let's get started. I think most presentations have a thank you towards the end. With this one, I'm going to start at the beginning. I think it's just teachers have such an enormous impact on outcomes in life, right? And I think, especially with hard things like programming and computer science, I think the teacher has a very important impact on whether the student likes the subject or goes on to program or be involved in computer science in the future. And some of my fondest memories include my teacher giving me my first Java book, or like sitting me down and explaining me a piece of code or debugging with me. So I've always had a soft spot for teachers who are teaching computer science and coding. And I understand like a lot of you might not be teachers, but if you're involved in this education space, I just want to say thank you. I think this is going to be one of the most impactful spaces. CS education is going to be one of the most impactful spaces for the future, and I think it's going to shape what we see and what is built in the future. So thank you for that. All right, so let's jump in. So Replit's mission is to bring the next billion software creators online, and this is an ambitious mission. And as engineers, every single thing we do at the company, we try to keep this question in mind: is how does this product feature, how does this undertaking actually contribute to the mission? Or, for example, even setting up this EdFest event actually help us succeed or move towards our mission. And we realize that there are two key pillars which are critical for us to achieve a mission. One is CS education, because that's the fundamental onboarding doorway to students and newcomers becoming software creators. And the second we think is AI, which is that we think that artificial intelligence is going to have a massive impact on how people learn and engage with software. So we try to think about this question about how do these two things work together, and what can we do at Replit to help using these things to help build the next billion software creators online. So just taking a step back, I'd just like to present how we actually think about AI at Replit, which might be slightly different from what the conventional narrative is. When AI was first conceived or was started to be worked on in the 1950s and the 1960s, there were these two dominant schools of thought. One was the school of thought which was championed by Marvin Minsky, which was this idea that we can induce intelligence in artificial beings, or like induce intelligence into computers. And a second school of thought was Licklider's school of thought, which was this idea that it's not about building intelligent machines, but it's about building the machine which can have the best symbiosis with man, and together they can have the intelligence is far greater than either of them can possess. So the way the way to think about it is artificial intelligence versus intelligence amplification. And at Replit, we strongly believe that a good way to think about AI and its impact on computer science programming and computer science education is this idea of intelligence amplification. So we try to think about this question is, what can we build and what can we do with new features and so on to amplify coding education? We're not trying to replace it. We're not trying to solve it, etc. We're trying to figure out what are the best things we can build, which can work hand in hand with education to amplify this enterprise of computer science teaching. So for the rest of this session, I'm going to demo some of our features. I'm going to demo three main features: code explanation, code generation, and semantic search. I hope I can make it interactive, and rather than talking too much about how it works and so on, I just want to show you what it can do. But more importantly for us, the importance of this session is we want to hear from you as teachers or people involved in the education space. What do you think about these features? What is some feedback, painful or not? What are some things we should look into? What are some things we are missing? The idea for this session is to for us to demo what we have and get your input on what we should do. So before I move on, David, do we have any concerns before I start demoing? Okay, I think everything looks okay. So I'm just going to jump into it. So I'm going to start with code explanation. So here I have a demo Replit environment setup, and I'm going to start demoing the code explain feature. So the way the code explain feature works is that you are given a piece of source code, and then this AI system is able to take in this piece of source code and explain to you what the source code does. So for example, here I just have a conditional loop, which is just simulating the computer asking for a user for a password, checking if the password is secret. If the password password is incorrect, ask for the password again. And the way we can use explain code here is as follows. We select the code which we want. For example, a student wants to be explained, or you want the AI to explain, and then we can right click and go and explain code. And then we get this output, step-by-step output, which is trying to explain in natural language, here being English, what that code is doing. So you can see it takes as a user input, stores in a variable, checks if the user input is equal to a password. If it's not equal to the password, ask again. And if it's correct, then you break out the while loop. So this is a quick demo of how the explain code feature works. Okay, so I'm gonna start demoing some more stuff about explain code. So one of the ways, at least David Morgan, who's a teacher and works at Replit, he shared And a potential way this feature is being used is to explain syntax. I'm not sure how many questions you get about, oh, what does this syntax do and so on. But like when I was learning programming, a large class of questions I had was like, okay, what does this syntax do? And for example, here in JavaScript, there is this ternary syntax, which is not very common to see, or it's non-obvious. And we can use this explain code feature to get an explanation of what that ternary operation does. And so now you can see if it's red, do this. If it's not, then do that. And so that's explaining the syntax. Another example is using try-catch. And explain code can now explain, okay, it tries to get the value, and if it fails, it logs a string. So we think, and obviously feel free to give feedback, is that this can start helping out with answering some of these, okay, what does the syntax do kind of questions. A second thing David shared with me, David the teacher shared with me, was that often teachers are trying to teach a concept, for example, like a for loop or something, but because learning programming and learning computer science has so many dependency relations, that means if you're learning something right now, you're depending on things you learned a week ago, students might get lost. So for example, here I've just contrived an example, which is if you're trying to teach loops, and a student's lost about, okay, what does this line do? Don't worry about it, that's going to be okay. Then the student can simply just go and look at and run explain code and get a quick sense without having to interrupt the entire class, or if they're shy to ask, for example. Another example is if you're teaching data types and typecasting. This piece of code that might not look very familiar to a student, and they can simply just select that and run explain code. And then the model will spit out, okay, print out the quotient variable with 2 decimal places. Another thing we hope to achieve is that students are excited, if they're excited about programming and looking at code online and so on, which might be often beyond their difficulty level, this tool still gives them some opportunity to engage with that code. For example, this is just a small code snippet to get the price of Bitcoin. And a student might find this online, and they might have not learned about requests, they might have not necessarily learned about API calls, JSON, and so on, but they can start at least engaging with the code by just asking explain, and they're not just staring at a bunch of symbols. So now the model is like, okay, you're importing a library, you're making a request. It gives at least a sequence of steps about what is going on, and then they can come back to you and ask you, okay, what is the JSON format? What is an API endpoint? But it's a tool for students to actually get started and engage with code if they want to. So these were some of the things I covered here. I'll take a quick pause here, and if anybody has any questions about this feature for code explanation. David, are we live? I hope everybody's good.
I just want to call out a question from Jason, asking if these are available on all REPLs. I think that means, like, is it available in any language and for hackers or not hackers?
Absolutely. Yeah, I should clarify that. So currently, code explanation, which I just demoed you, and code generation, which I'm going to demo next, are available for all hacker users, to 100% of our hacker users, which are our paid users. We are currently still thinking about how they would be integrated into education, teams for education, and so on. But explanation generation available to all hacker users. Semantic search, which is the third feature I'll demonstrate, is something which is still in the works, but it's going to be, we have internally shipped it, and we're going to be shipping it to hacker users again. But we'd love to hear from you about how you think, like, these features should they be a part of the education pack? How should they be a part of education pack, and so on? Any other questions? Otherwise, I'll move forward.
We got another question. Is your intention that the feature will cope with longer sequences of code, such as more complex algorithms?
Absolutely. So right now I demoed you with very small snippets of code, but we are testing out how well the models can work with very, very large pieces of code. For example, like, can you even take an entire code repository and then the code can be answer, okay, this is where the code is, this part of the system is here, this part of the system is there. So we're still working on it. It's a harder problem because the model can output a lot of things, and we are trying to like ensure that the model outputs precise and correct things rather than not. But that's one of the things, and I'll be talking a little bit about it towards the end about what's next for us. But absolutely, that's the plan. If you can get like a model which can even explain large and more complex pieces of code to anybody, that's something we're definitely trying to do. Okay, so I'm gonna move on here. Sorry, I'm a little tight for time, but happy to definitely we'll have a lot of discussion towards the end. So I'm gonna move on to the second feature, which is code generation. And the way code generation works is that it takes in a prompt in natural language, which describes what you want a piece of code to do. And for that prompt, it spits out, it gives you the result, it gives you a piece of code which actually does what you want to do as described in the prompt. So I'm going to just show you something. So here, for example, I want some code which gets me alternate elements in the list. So I'll say, so I right-clicked, I clicked on generate code, and I said, so for this prompt, the model understood, okay, you want a piece of code which gets you alternate elements in the list, and then it gives you even an example saying, okay, if you want the alternate elements in the list, you can use this kind of syntax. And that's one of the main use cases we have seen come up again and again, which is if a student has a concept of they want to do something, but they don't necessarily know the syntax or they don't remember the syntax, this is a very quick solution, a quick tool to get for them to like quickly get the syntax for what they want to do. So just another example, for example, you want to reverse a list, and you can say a student doesn't know what the syntax for reversing a list is in Python because they're just starting out. They can use this and they can get a code which gives them, okay, this is how you reverse a list, for example. Another thing we hope that this feature can be useful for is to enable teachers to adapt lessons on the fly. So because instead of having to focus on getting runnable code, you're able to just engage with students, and for whatever question they ask, you're able to get working code very quickly without having to worry about preparing the code in advance, debugging the code in class, and so on. So for example, here, you're trying to teach recursive functions, and you're describing and explaining the Fibonacci function. And some student raises their hand and says, okay, how do we do it iteratively instead of recursion? So, and you don't necessarily have, with this tool, you won't have to prepare the code always, and you can just simply rely on generate code to do so. And you say, okay, right, and live in class, you can adapt the content which you have to help you teach and answer students' questions. And we hope this reduces the burden for you and enables you to make the lessons more as interactive as possible without having to worry about like syntax, debugging, and so on. So I can, for example, I can just insert it in the editor and you can do a comparison. One of the things we also hope to do is allow students to use this tool to like try things on their own. So if a student has been learning Python in class and wants to start delving into building small servers with this, they can start relying on they can use this tool to assist them. And in fact, it kind of like enhances your ability to help them out beyond just the classroom. So I can, for example, if students interested in creating a Flask app, which is the most simple Python way to like get a server up, and they can simply start using this tool, try it out on their own, and then later perhaps even come back to you and ask you during office hours or something, oh, hey, I'm trying to think of a web app. This is what I have. What is the route? And so on. But we hope that this enables and encourages them, and in fact, makes them more interested in trying things out their own without being like, oh, I don't know what to do now. So yeah, just describing some of the things we think, in ways we think it can be useful for teachers. Any questions I can answer quickly about code generation? Okay, for some reason, I don't see any questions right now. All right, David, I'll be banking on you. I hope everything's good.
I don't see any additional questions. Someone asked about in the Q&A if this would work if they had Hacker. Would it apply to their students? The answer is no. Hacker benefits only apply to a personal account.
Yeah. Thank you, Leah. Okay. So let's move on to semantic search. And obviously, we'll have a lot of time to discuss towards the end. So semantic search, let me just demonstrate it first, and then we can explain it. So I go on a REPL, and I can say, go on search code here. And I say, OK, binary search. I'm going to disable this option for now. I'll come to it. And I press search. OK. Classic Replit. We have a internal joke that demos always fail. So I'm just gonna, if you give me a second, I'm just gonna pull up a pre-prepared video for this feature, and then I'll walk you through it. Okay. Sorry, bear with me. Just give me a second, please. Because I know exactly why this is happening, because somebody right now is exactly working on this feature. Like, in fact, we coordinated before it. I was like, please don't break anything in production, but like, I think it's just how things go here. And that's totally okay. So let me just pull up a video. Right, so semantic search, basically the way it works is you give it a query, and you'll see it in the video. For example, here we want code for binary search. And what this will do is it will search over the entire repo, over entire code available in GitHub, on GitHub public repos, and give you results. So if you can see, so it's giving you a bunch of results for that query. And just targeted functions. It's not a web page. It's a piece of code which is doing exactly what you want to do as you describe it in the prompt. So you can see there are multiple things. And then the good part is, for a particular result, we take you to the source of that result. So as you can see, we pressed for that particular result, we took you to the exact GitHub piece of code for that. One of the ways I think this might be useful, it's something I've personally tried to do, is learning from examples. So if you give a student a problem X, they can use, you give them a problem X, they have a solution. What they can do is use this to compare their solution with multiple other solutions. And I think this idea of being able to learn by comparison is quite powerful. And that's something I've particularly used to learn. I do something, I check, okay, how other people have done it, and see the differences. And that might even make up for some good discussion content in class. So that was that. I'm going to give you another example. If, for example, here I'm checking if a number is prime. So, and then you can get a bunch of results, which are solutions for that prompt, for the query. And then you can compare these multiple results. So this is another detail of the feature I want to emphasize, is that the search is contextual. What that means is it's able to take into account what all you have already written, what you are programming with, and use it to give you more accurate results. So for example, here, if I will have a query to parse a file, and so I'm going to go search for it. And I'm going to, for now to just demonstrate, I'll disable the contextual option. And I'm going to say, get me results for parsing a file. And then you'll see that you'll get a bunch of results for this general problem of parsing a file. Now, I'm trying to show that this feature is context aware. So I'm basically just putting a line saying importing parsing for XML files. And if I use this now in my, if I enable my contextual search and I put in the same query for parsing a file, the feature is smart enough to realize, okay, I need to give you code which parses XML files. So essentially, this search tool is contextually aware, and it'll give you highly relevant features to someone's query. The last thing I want to demonstrate, I hope this is valuable, is this idea that I think, like the way you learn a language by reading, like English was not my first language. I learned a lot of English by reading books and so on. I think to some extent that idea transfers to programming too. It's that you can learn how to program by reading a lot of code. And Paul Graham has this idea. Paul Graham, the founder of Y Combinator, has this idea that you can learn to code by reading a lot of good code. And one of the things, at least I've tried to do with this tool, is can we make it so that it allows people to go find relevant code to read and acts as a tool which surfaces relevant code for students to read and learn from. So for example, I'm searching for merge sort implementation in JavaScript, and you will get a bunch of results to which you can read through and understand and learn more and read about merge sort and hopefully learn from that. Okay, sorry, I'm going to just switch back to my previous mode of operation. Yep. So yeah, look at multiple ways to solve the problem. Learn by comparison, learn by looking at programs. Here are some ideas. Any questions in semantic search I can answer?
I don't see any questions in the chat right now.
I hope the Q&A chat is working.
Yeah, I think everything's good. If anyone has any questions, feel free to pop them in the chat.
Okay, great. So just want to take some time to talk about upcoming features. So one of the things we're working on right now is the recommendations. So we're trying to build a recommendation engine which is able to, based on users' preferences or what they want to, what they're looking at, it can recommend other pieces, other programs, and other REPLs, for example, on a platform to look at. So if a student's interested in HTML websites, our recommendation engine will take that into account and start showing them or start giving them a feed of other HTML websites they can look at. So that's one feature. Secondly, as somebody asked earlier, we're trying to improve our code generation completion, code generation explanation, and even make it into a code completion feature so that it can operate on much more complex code and much more larger pieces of code. Instead of having to do multiple lines, you can do multiple files, and then it can give you an explanation. So that's something we're working on. And lastly, we're trying to expand a lot of these capabilities, specifically search across multiple languages. For example, Java is popular, JavaScript is popular, Python's obviously very commonly used. We are trying to expand it to Go and so on, and also taking into account multiple other resources rather than just GitHub. And that's just the start of it. We're actually trying to work on a lot more. But I think the key idea again is that we want to hear from you as people who are teaching students what AI features should be built to actually help you and your students. And I was hoping we could get a conversation started about that. I'm an engineer. I'm here to come out and take your feedback about what we should build. What do you think is problematic? What do you think we should actually focus on? What do you think as teachers will be more useful? So yeah, I'll be super happy to get all this input in the chat or any other how. But yeah, that's all I have for you today, and thank you so much for listening. So yeah, happy to hear any ideas about what we can do for our AI stuff to help you out. David, if you see any input in the chat or the Q&A, just surface it.
No questions. I think everyone's just super psyched about this feature. And yeah, we do have a session code. It's pinned to the conversation. It's unit testing 2.3.
Any ideas at all? I'm curious about how we can think about AI for assessment, for example. How much of assessments can be automated using these things? Because if you have a model which can understand code, can we try to build something for teachers to help you automatically, for example, assess or automatically give feedback, or even as trivially like generate problem sets. I mean, these are just some of the ideas we've been thinking about, but we'd love to hear like any particular ones you have.
Madhav, do you mind if I share your Twitter handle in the chat in case
Sure.
people want to keep the conversation going?
For sure, absolutely, yeah. And like, just feel free to reach out to any of us.
Yeah.
Everybody's happy to hear about this. Jason, for the code, we'll give right now, because a lot of these features are in preview. But if you go to if you're a hacker user, you should be able to like just try things out on your own. Apart from that, if you particularly like, I'll append this REPL, upload this REPL to the web, and then append it to the slides. Right now, it's all local because it's pretty much like from development. I'm just showing you everything. Okay, so I'm trying to like find some. Okay, there's a lot of great info. So let me see. Script. Yeah, that's something that's Michael, you raise a good point. It's like, yeah, how do you actually, like, if you have such powerful generation capabilities, like how do you just prevent people from like copy pasting all the time, right? Or like generate once, generate this, and just put it together. And like, because you're trying to teach computational thinking more than just copy pasting, and that's something obviously we're trying to think about. But like, to be honest, we don't have the best intuition about it, because I think teachers have a better intuition about, okay, what does it take to actually teach computational thinking? So yeah, that's a good point, and I think we all should think about it. AI for assessment, we think it's definitely going to be powerful. Right, absolutely. So yeah, because if you're giving students assignments, you don't want them to just use generate code or explain code to answer everything, right? And that's something we'll be thinking about. If we do teams for education and we have these AI features, can we we would like the teacher to be able to control when they can use the code generation feature, code explanation feature, etc. So that's definitely something we'll think about. And yeah, any input you can direct to me at Twitter, or you can just like email us or something. David, I think we're running out of time.
Yeah, I think we're slightly over.
Okay.
But if anyone has any questions, definitely feel free to ask. I think I'm totally fine with staying a few minutes after.
Sure.
Yeah, I think that's technically the end of the official session. So if anyone feels the need to leave, we won't hold you.
Absolutely. And yeah, if you ever want to talk about it, just like, you can reach out. I can even put my email here, I think. Yeah, we'd just love to get as much input as we can about what we should do. Great. Yeah, so that's something actually I've been particularly interested about, and like trying to like get it happen in Replit. So far, right now we don't have it. TPUs definitely we don't have on the roadmap, but we are trying to assess whether we can have GPU. We can start having GPU REPLs, and this is a very like highly requested feature. The key, and I'll share why we haven't done it so far. The key problem is the economics. Is how can we instead of charging you the same amount which Google Cloud charges you for GPUs, which is quite expensive, can we actually make it work with the same kind of subscription plans we have, and so on? And that's actually not so much a business problem. It's actually a technical problem, which is like, can you have a limited number of GPUs and then allow everybody to share over that, and like at a cheap cost? And that's something we're trying to do. But like, I think definitely this is something we're working on. I don't have a very clear answer for you, like that this state it's going to happen, but we're just trying to figure it out. And that's something we definitely want to do, like have GPU REPLs. TPUs will be harder because it's hardware proprietary, and then you will be bound to things, Google's platform and so on. But like GPU is definitely something we want to get to ASAP. Yep, happy to answer any more questions. Feel free to reach out. Yeah, just AI team would love all your input about what we can do for like AI features for education. Oh, Michael, sorry, I fix all my students' indents and curly braces. Yeah, that's definitely. I think that's a great idea. Syntax correction. I think it's very doable, actually. Yeah, let me take that back to my team.